Now for the next things we're going to talk about, this is factors affecting solubility of a gas. And if you notice, they're a little bit different than the way solids behave, so it's important to make note of how they're different. And the first way is temperature. If you look at the graph on the right, you can already see for the solubility curves that this is different than what we've seen on the other graphs. For all four substances here, as temperature increases, the solubility is actually going to decrease. Now to understand this, we got to think back to the beginning of the year and what we know about gas molecules. Compared to a solid, gas molecules are moving much faster. The solid's just vibrating in place, but the gas is moving all over the place. Now, as we increase the temperature, those gas molecules are going to move faster. And if they move too fast, they're going to actually be able to escape the solution. And so when they leave the solution, they're no longer dissolved. So as you increase temperature, those molecules move faster and they're able to leave. Think about soda. Carbonated soft drinks are more bubbly if you store them in a refrigerator, because what you're doing is you're lowering the temperature, you're lowering the speed of that molecule, and it allows it to stay within the soda. On a hot day, if you leave your soda out, it ends up going flat because the carbonation is a result, or leaving is a result of the temperature increasing, which allows those molecules to escape from going too fast. Now the final thing we're going to talk about in this video is pressure. For gases, the higher the pressure, the more soluble the gas is. And if you think again back to soda, whenever they put carbonation into the bottle at the plant, first thing they do is they apply a lot of pressure and then seal off that cap. And the moment you open that cap, you hear that release of sound. That's the carbonation escaping because you're decreasing the pressure. So if we look at this picture here, pressure is going to force those gas particles into the spaces between the liquid particles. More pressure means more dissolved gas. If we're not increasing the pressure enough, then those gas molecules are actually going to be able to escape. So remember, for gases, the higher the pressure, the more soluble it is, or the more dissolved it actually is. Again, just think about soda. As you open it, the CO2 is going to escape because it's no longer underneath that pressure. So there's nothing holding those molecules in. The last thing you want to note is pressure has no effect on a solid. Since those particles are already close together, we can't really combine them any closer. So for pressure, we need to remember it only has an effect on gases. It does not affect solids.